point we've been working with vectors, but we haven't properly defined them or showed how to do calculations or draw them essentially. So a vector essentially has two things, magnitude and direction. Okay, so the length of the vector is the magnitude, and then the arrow is going to give you the direction. So you need an initial point and you need a terminal point for it to be a vector essentially. Okay. So even though there's an arrow on it, it doesn't mean that it goes forever because it does terminate at that point essentially. So if you put the double lines, it looks like a double absolute value. That actually means magnitude. It does not mean double absolute value. That's not a thing. Okay, so use this funny little v to represent a vector or something like that. So otherwise, you're just a scalar quantity, right? But you have magnitude but no direction. So for example, if the classroom is 75 degrees Fahrenheit, that has a scale, right? But there's no direction to that. So that is a scalar quantity essentially, right? If you drive 60 miles per hour due north, that is a vector that you can draw because it has a magnitude of the miles per hour and has a direction of due north. So that's actually a vector. If I throw whiteboard marker 20 feet at the window, it is facing the sun to the east, right? That can be drawn as a vector because it's 20 feet is the magnitude and the direction is east essentially, right? If I'm almost 6 feet tall, that's just a scalar, right? Just a measurement. That is not a vector. Okay. Whoops. Okay, so what does it mean to be equal vectors? You need to have both, not one or the other. You need to have the same magnitude and direction. Okay, so the first one, if you look at those two, they're the same length and they have the same direction. Therefore, those are equal vectors, essentially. If I look at these, they have the same length, right? But these are clearly different directions because this one's going in a different direction. These ones have the same length, but they're going in opposite directions, so that's not good. And then these ones are going the same direction, but they are not the same length. So none of these are equal vectors for different reasons. The first one being, yes, they're the same length, but they have different directions, right? This one's going up and down, slightly different. These are the same length, right? Same magnitude, but they're going opposite directions, so those are not equal essentially. Okay, and the last one, those are the same direction, but they're different in magnitude. So obviously one is almost double the other one. I don't like quite what it is, but it's definitely not equal. Okay, okay. So there's a ways to calculate magnitude and direction. One is the distance formula for this. So we can do a little math here. Oops, wrong screen. Okay, there's our typical distance formula from basic geometry. So we'll use our double lines here. There we go. And we'll put in a U. We'll make that the vector U though. So I'll change my style to user2. There we go. And then we'll do the formula for this essentially. Okay. So my x values, if I look over here, for this u, this is my u right here. I have -3, and 0, 3. So my x values are -3 and 0, right? And then my y values are -3 and 3, right? Okay, make this shrink this down a little bit, right? Because I'm just looking at this vector here, the vector u. Come on, pen. And these are my coordinates x and y, right? Okay. So if I do this, copy, paste, that's going to be what? 9, right? And this will be -6 squared will be 36, correct? So that is the square root of 45, which is the square root of 9 times 5, so that's 335, correct? So essentially this is 3 root 5 is my magnitude essentially, right? So either this one or this one is fine here. The book answer will probably want the latter, but we'll take it. Okay, let's look at vector v. All right, we'll just copy paste. We can slightly cheat here. So if I switch this one to vector v, all right, so we'll just change that to a v, change that to a v. We've got to slightly change these values because it's 0, 0, and 3, 6, right? So we have 0 and negative 3. All right, so I'm going to do an extra parentheses there. And then we have 0 and 6. Okay, so that's still going to be 9 and 36, which gives us the same answer essentially. So the result is they have the same magnitude, is essentially what we're saying. Okay, the same magnitude. Okay. All right, what about direction? So look at these two vectors here. We could do slope as direction, right? So if we do slope, right? This is our coordinates for u here, right? Do slope. All right, whoop, wrong screen. All right, there's our slope formula there. Good old high school slope, right? So we do our y values. Our y values are 6 minus 2, right? And our x values are negative 2 minus negative 5. Right, so that's going to give us a fractional value of 4/3 as our direction. We'll also be doing this in terms of bearing later on, right? Okay, well, what about the v? Well, we'll take a look here. So we do this one and change the values for v. It's 2 and 2 and 5 and 6. So 6 minus 2 and 5 minus 2, which gives us 4/3. So these have the same direction. So I can copy what I had before and paste that. Oh, no, I want to do that. Math type. Have the same direction. What did I say? 4/3. Okay. All right. So it means they're equal vectors. These have the same magnitude and direction, essentially. Okay. Scalar multiples. That's going to involve a little bit of drawing here. So let's get this out of the way. Okay. So let's say we have vectors, right? So this is my vector v. So if I double it, 2v, it just doubles in length, stays the same direction. If I half of it, it stays the same direction, just half the length or half the magnitude. If you multiply it by a negative, it increases by that, so it's 1.5 times, but it also changes the direction. Okay, so you have to be mindful of that. So if I do 1.5w, it's the same vector and the same direction, just 1.5 times the length. If I do negative 2w, it's double the vector, but in the opposite direction, essentially. Okay, so you can draw that, copy, paste. There we go. Okay. We can scale that up. Let's do wrap and square. Okay. So notice when I drew these, that the arrows are the same on these ones, but the opposite in this one. Okay.